here. Hey guys, it's Visto. I am here to walk you through the last section of chapter 2, which is 2.8 on solving inequalities. So what's cool is this whole chapter we've been talking about different things with polynomials and power functions and rational functions and graphs of rationals and we've kind of just been blending all of these topics together, all focused on the idea of around essentially polynomials and algebraic functions like that. And now we're going to take some of those ideas and we're going to add in something new called a sign chart. So how do we make a sign chart and how do we interpret a sign chart? Because lots of information lives in a sign chart. It's just a matter of we have to be able to know what we're looking at. So I'm going to walk you through a couple examples. Here's our first one. The first one looks like this. I'm given f of x. Right now we're just going to talk about making a sign chart. I promise we'll talk about how to use one in one of the later examples. So here's some polynomial. And the reason it's in factored form is it's going to be a lot more helpful for us to have it in factored form. So let's run through some information for this particular polynomial. First of all, the degree of it is 6. That comes from the 2 on the x squared plus the 1 from the x plus 3 plus the exponent of 3 on the last one to get a degree of 6. The leading coefficient is negative. The zeros are at 0, at negative 3, and at 4. The 0, let me write this out a little more detail. 0 is a 0, but it has a multiplicity of 2. That's probably an important thing that we cover that quick. Negative 3 just has multiplicity 1, and then 4 has multiplicity 3. Sorry about that. Now, if I was going to draw the graph of this, here's some things I could do. I know my spacing's not great, but it'll be okay because I really just care about the zeros. Okay? Those zeros tell me I have a point at 0, I have a point at negative 3, and I have a point at 4 multiplicity 3. I also know that this is an even function, or excuse me, it is an even degree. And since it has an even degree, the arrows are both pointed the same direction. Leading coefficient negative means both arrows are going to be pointed down. So my graph's going to have some sort of shape. The first 0 as I work up to it is negative 3, and it has multiplicity 1. So I'm just going to pass straight through. Then I'm going to come down to 0, and I'm going to bounce at 0 because of the multiplicity 2. And then I'm going to come back down with a wiggle because of the multiplicity 3. So I'm not going to just pass smoothly straight through. I got to kind of flatten out with a wiggle. My graph looks something like this. Is this a perfect graph? No. Is it a graph? Yes. That's a graph. A sign chart tries to capture what we see in that graph. So let's talk about the sign chart for this function. First of all, our sign chart is formed on a number line. And then on that number line, I'm going to mark off key numbers. One key number is negative 3, one is 0, and one is 4. If you're not sure where those are coming from, they are the zeros are the key numbers that we want. Okay. Now, the sign chart captures, is the graph positive or negative in a specific range? First of all, at each one of these key spots, the graph equals 0. But in other spots, from negative infinity to negative 3, our graph is negative. It's below the x-axis. From negative 3 to 0, it's positive. From 0 to 4, it's still positive. And from 4 to infinity, it's negative again. So I have kind of 4 parts of the graph, and this is what's happening in each of those parts. Now, if you're ever not sure because you don't have a picture, we'll talk about some strategies, but this is basically what a sign chart does for us. Here's how we use it to deal with inequalities. So here's an example. 2x plus 1 over x plus 3, x minus 1 is less than 0. Oofda. Here's what we're going to do first. The first thing we're going to do is we're going to look for those key x values. Whoops. Okay. Here's where they're going to come from. In the numerator, that gives me a key x value of negative 1/2. Because I could set that equal to 0 and I could solve. The denominator is going to give me a key x value of negative 3 and another key x value of 1. So there's my 3 key x values. And the reason I care so much about those is because remember, my sign chart focuses on those key x values, right? We make a number line and we focus on those. So here we go, sign chart time. So our second step is to draw our sign chart. One key x value happens at negative 1/2. Oh, hang on. I'm going to start with my negative 3 first. The reason I'm starting with negative 3 is I want to build least to greatest. Now, is my spacing on my number line good? No. Do I care? No. Now, can x be negative 3? Well, technically no, because it's in the denominator. Same with 1. So as I draw my sign chart, I care about what are my key x's, label my zeros and my undefines, and then decide on plus and minus. Okay? So now I have to decide, am I positive or am I negative? So this range of my sign chart right here is negative infinity to negative 3. So I might pick a number like negative 10. If I pick negative 10, because that's in that range, my numerator, if I pick negative 10, my numerator is going to be negative 19 over negative 7 times negative 11, and I'm going to end up with a negative number on top and a positive. That means this gap, any number in that gap is negative, because negative divided by positive is negative. In the gap from negative 3 to negative 1/2, negative 2 lives in that gap. If I use negative 2, my top is negative 1. Nope, sorry. My top would be negative 3 as the result. My bottom would be a positive 1 times a negative 3 again, and I end up with negative over negative, and that means my graph and my equation are positive here. In this gap, I've got negative 1/2 to 1. 0 might be a good option for that gap. That would be 1 over 3 times negative 1. It's a positive divided by a negative. There's a negative in that gap. And then last but not least, this final stretch from 1 to infinity, maybe I'll pick 4. 4 gives me a positive up high, positive here times a positive. Everything is positive, so I'm going to fill in my positive. So there's my sign chart. Now I need to use my sign chart. The original question, said, where is this less than 0? Less than 0 means negative numbers. Where on my sign chart is it negative? Well, it's negative from negative infinity up to negative 3. It restarts being negative at negative 1/2 to 1. Notice I'm using parentheses because of this less than right here. I don't actually want to equal 0, and so I'm going to use parentheses to show that I'm not actually going to let it equal 0, I'm just going to let it get up to 0. We're going to do one more example quick. I won't write the steps on the side this time. I know this is weird and different, but it's kind of cool, and I promise we're going to take it slowly enough where you're going to get it. So I should probably box my answer, sorry. Okay, so here's my next one. X minus 3 square root of x plus 1 greater than or equal to 0. What are my key x numbers? Well, my key x number from the first set of parentheses is x equals 3, and from the second, it's x equals negative 1. Those are my key x's. Then it says, it's time to draw the sign chart, Visto. My first, remember we're going to build, okay, so there's where I'm at. As I draw my sign chart, I label my key x's first. Done. Now I'm going to label 0 undefined. If I put negative 1 into this, I get 0 under my square root, so this is going to equal 0. I put 3 in, I get 0. Undefineds really only happen when you have a denominator. Then I've done that. Now I need to decide positives and negatives. So here we go. Remember this first gap is negative infinity, negative 1. If I put negative 2 in here, I get negative 5 in the parentheses, and I get the square root of negative 1. I don't want anything having to do with an I. So I'm just going to write und right here, because anytime I have something in this gap, it's going to trigger a negative square root. So that's a major bummer. Let's try the next gap, negative 1 to 3. Okay? So if I pick a number in there, I might pick 0. 0 minus 3 is negative 3 in the parentheses times the square root of 1. It's a negative times a positive, which overall means that this gap is negative answers. And then I come to the end, 3 to infinity, I'm going to pick 5. 5 minus 3 is 2 times the square root of 6. Everything here is positive. So what we know is in these gaps, all of it follows the same pattern. So if I pick 5 and 5 is positive, that means if I tried 6, 6 would give me a positive result. 7 would give me a positive result. 8 would give me a positive result. 9 would give me a positive result. 10, everything in that stretch gives me a positive result. So I've set my pluses and my minuses up. Oops. Now I need to use my sign chart. This problem is asking me greater than or equal to 0. So that means I need zeros and positives. Well, first I see a 0 at negative 1. So I need the negative 1 in my answer. Before negative 1 is undefined, after negative 1 is negative. But I for sure need the negative 1. And then since I have the equal to part, I'm going to use the bracket on 3 and go forever to infinity. Ta-da! This is weird, new, and different. We're going to get lots of opportunities to practice this. I hope you're doing well. Keep me posted if there's anything you need. You guys rock.